And let's continue our step number 6. You remember that in step number 5, you already have the summation for each column. In step number 6, we'll just copy the summation part. And the one at the bottom, the R, is the formula. That is our N. Our N again is the number of students. We have 1, 2, 3, 4, 5. So our N will be 5. Our E of XY, that's the last column. Let me first make an edit. Let's make some markings so that you could follow. Here. The E of XY is this one. The E of X refers to this one. You multiply by E of Y, summation of Y, this one. The N again is still 5 because we have 5 students. The summation of the X squared column is this. And the next is, you subtract it by the summation of X. We follow again, but we need to square it. Then, our N is 5 again, you multiply. Our E of Y squared, summation of Y squared, is for the Y squared column, this one. And then, you subtract it by summation of Y here. Then, we'll square it. In our next slide, we are going to check on it. We'll substitute. So step 6 is substitute the values obtained in the formula. Here, if you check, our N is Y, 5. And then, we'll get first to make some markings. Our N is 5. You check it's 5. You multiply by summation of EXY, that's 351. Here it's 351. Subtract it by E of X. Our E of X is 41. Check. You multiply by the summation of Y, this one, 40. Over. The square root is for the whole denominator. So you multiply this one with this one. Our N is still 5. Then E of X squared is 383. We copy. Subtract minus by E of X. Then you square it. Our E of X is 41. Go back to 41. Still, you square it. Then, you close the bracket. We'll have the other one. N is still 5. E of Y squared is 334. That's 334. Minus the 40. That's E of Y. Summation of Y. 40. Then you square it. Now, let's try solving. If you'll solve, in the numerator part, you'll get 115. In the denominator part, the 234 is for the first one. I'm referring to this one. The 234 is this one, while the 70 is for the other one. We need to multiply the 2 before we find the square root. So, as we multiply both at the bottom and have the square root, our R is 0.90. That is our Pearson R, or our Pearson product moment correlation coefficient. Now, we interpret how to do it. The value R is called Pearson correlation coefficient. It indicates the degree of relationship between two variables. So our R will tell us of the strength and the direction. How to do it? By the way, this is a formula that we have used a while ago, and it tells us the strength of the correlation in computing the R. It is symbolized as R. That's why we commonly call it the R, or the Pearson R, in honor of a statistician who did a lot of research in this area. We have Carl Pearson. So it's called Pearson R. Now, how do we interpret it? Here's a table developed by Pearson, and we check on our value. For example, our value is 0.90, right? We check on the table. It falls in the very high. Since it has a positive symbol, then we say there's a very high positive relationship. So we interpret there is a very high based on 0.90. It's positive. So we say that the scores in stat and the scores in physics have a very high positive correlation. Now, how do we interpret it? First, other interpretations. If our trend line points to the right and all the points in the trend line, there's a perfect positive correlation. And our computed R is 1. Exactly 1. We go back to the table. If it's positive 1, it's perfect. If it's negative 1, it's still perfect. Second, if our trend line goes down and all the points are in the trend line, there is a perfect negative correlation. And the computed R is negative 1. Number 3, if there's no correlation, then our computed value is 0. Number 4, the absolute value of the R indicates the strength, while the direction is in the positive or the negative side. So if our correlation is a negative, like R is negative 0.20, then it's a negative correlation. Again, how do you describe relationships? It's based on strength and direction. And for the strength, we refer to this table. That ends our discussion for today.